Isaac Newton is considered by many to be one of the most important scientists in history. He was born on January 4, 1643 in Woolsthorpe, England. Isaac Newton loved studying at school. His mother actually took him out of school to work on the farm, but he had no interest, and soon enough he was back in school. He attended Cambridge University and potentially later became a professor of mathematics at the same university. However, he had to leave Cambridge because the Black Plague was spreading around. He left Woolsthorpe to develop his theories on calculus, gravity, and the topic that we'll be discussing today, Newton's 3 laws of motion. Alright, Vrushank, please explain the first law.
So Newton has presented us with 3 laws, and I'll be doing the first one. So the first law states that an object will stay still or move at a constant speed until unless another force is acted upon it. So what this means is that this ball will not move and stay still until unless I push it, or the wind acts upon it, or some other external force does something to it. Or the ball will go at a constant speed in a straight line until something else happens, like somebody else touches it, wind pushes it, there's friction which stops it. So that's basically what the first law states.
Although Vrushank's experiment was kind of dull, it still explained the first law of motion. The object was in rest, and it remained at rest. As in motion, the unbalanced force of friction caused it to slow down and stop, which is why it didn't remain in motion. Alright, Prashil, it's now your turn.
Now, let's visualize Newton's second law. Here, we have an empty shopping cart. As you can see, a little push is needed to achieve a greater acceleration. Now, we have a shopping cart that has more mass in it. As you can see, if I give it a little push, as I did before, it's not going to achieve the same acceleration as it did on an empty shopping cart. Newton's second law states that force equals mass times acceleration. But since we're taking acceleration into account, you could say acceleration equals force divided by mass. In other words, if assuming the force is same, if a mass increases, the acceleration decreases. And if mass decreases, acceleration increases.
Alright, thank you, Prashil, for explaining the second law. Partha, it's now your turn to explain the third law.
Okay, Newton's third law of motion states that for every action there's an equal or opposite reaction. In other words, when two similar forces act on an object, the two forces will end up cancelling each other out. In that example, I'll use a balloon which I fill up with air and I will let go of it. The air inside the balloon will face down, which will act like a propeller and make the balloon go up.
As you guys saw in my experiment, there were 2 similar forces that acted in opposite ways. While one force went down, which was the air inside the balloon, the other force went up, which was the balloon. And since these 2 forces acted in opposite ways, this is an example of Newton's third law of motion.
Alright, let's summarize the 3 laws. Newton's first law of motion states that an object at rest tends to stay at rest, and an object in motion will tend to stay in motion unless acted upon by an unbalanced force. Let's suppose that we have an object on the floor. We have the force of gravity that's pushing down, and then the force of the floor is pushing back up. This illustrates that the forces on the object are balanced. Alright, now on to the second law. As we learned from the first law, the presence of an unbalanced force will accelerate an object, meaning that it will change either the speed or direction, or quite possibly both. Newton's second law of motion states that the behavior of objects of all existing forces are not balanced, meaning that acceleration is based upon the mass of the object and the net force being placed upon it. The equation is net force is equal to mass times acceleration, and through algebra we know that acceleration equals net force over mass, saying that if net force were to remain constant, as mass increases, acceleration will decrease, but as mass decreases, acceleration will increase, but that's assuming that the net force is the same. Newton's third law states that for every interaction there is an equal and opposite reaction. This means that for every interaction, there are a pair of forces acting on the interacting objects. So let's say that if I were to place my hand on my desk, which I am, I'm exerting a force onto the desk, and at the same time the desk is exerting a force on my hand at an equal amount. However, it's in the opposite direction. To sum it up, it means that I'm exerting a force down at the desk, and at the same time the desk is exerting a force up at the same amount. Well, I guess that wraps up our video. Thanks for watching.